Okay, everyone, so welcome back once again. Now, in this lecture, I'll be talking about a skewness into a data set. So, there is something called as positive, there is something called as negative, and there is something called as a zero skewness. So, let's try to understand that what is the meaning of a positive, negative, or a zero skewness, and how this calculation is going to happen, plus what is the benefit of finding out a skewness into a data set. So let me share my screen and let's talk about one data point. Yeah, not one data point. So I'm going to talk about three different kind of a data point to show you all three different kind of a skewness. But first of all, we have to understand that why we are even trying to like find out the skewness into a data set. So skewness in data. Yeah. So basically, in theory, if I'm going to talk about a skewness, so basically this skewness is going to measure that how asymmetric my data set is, or how my data set is been distributed by the way. You must have seen this kind of a normal distribution curve. So here, so if I'm able to plot data on this normal distribution, or with the help of a probability density function, if I'm going to plot the data, and if my data set is symmetrically distributed across its mean, so I will be able to find out a equal amount of a data on both the side, and eventually my data set is going to form this kind of a curve, right? A bell-shaped curve, you can say. But sometimes, so you will be able to see a curve something like this, or sometime you will be able to see a curve maybe something like this. Yeah, so not exactly, but yeah, so maybe something like this you will be able to see. So where you will be able to find out some of your data, right? Some of your data, so which is helping this curve to get formed on a positive side, or you can say there is a tail on this right hand side you will be able to find out. With respect to some of this data, you will be able to find out a tail on a negative side, or you can say on a left hand side. Now, what is a meaning of this? And technically, it's called as skewness. So this is basically a data with a zero skewness. Now, this is having a positive skewness, or you can say a right skewed data. So basically a right skewed data, or maybe you can say a positive skewness. I have already mentioned about that. On this, you can say as a left skewed data or a negative skewness. So how we will be able to find out that my data set is negatively skewed, or my data set is positively skewed, or whether I have a data set with a zero skewness. So here there is a formula to find out this skewness, and it says that, so there is a formula to find out this skewness. It says that total number of data divided by total number of data minus 1, total number of data minus 2, into a summation of data itself, so xi, and its mean divided by a standard deviation of cube. So this is going to give you the skewness. This is basically a skewness formula. And if it is going to be 0, in that case it's having a 0 skewness into a data set. And if it is going to give you a negative value, so my data set is negatively skewed, and if it is going to give you a positive value, my data set is technically positively skewed. And we all are aware about all of these things, right? So n is nothing but a number of a data set, xi is nothing but a data set itself, the x bar is nothing but a mean of the data. This is a standard deviation of the data set to the power cube, summation of all of these things. So here, let's suppose if I'm going to take a data, so I'm going to take a data, I'm going to name it as a data 1. And inside this data, I have a value called as 10, 12, and then 13, and then 14, and then 15, and then 18, and then 30. Yeah, and then 30. So this is my data number 1. Now, similarly, so I have a data number 2, and I have a certain value inside the data. So 2 I have, 10 I have, then 12 I have, 13 I have, 14 I have, 15 I have, and I have basically 16. And we have technically a data number 3 And inside this data, I have a value like a 10 and then 11 and then 12 and then 13 and then 14 and 15 and then 16. Yeah. So this is the data set I have, these three data sets. Now I have to find out that my data set 1, 2 and 3 is having a 0 skewness, is having a negative skewness, or it is having a positive skewness. As this data set is very, very small, so just by looking into this data, you will be able to even observe. So let's suppose if I'm observing this data number 1. So obviously I can find out that, okay, so all of this data set is ranging between like a 10 to 18, let's suppose. And this is having like high value, so higher than the other data set that we have, or the other data variation that I'm able to see. And in this data, so again my data set is ranging between a certain limit, but I have one value which is having a very less magnitude, or you can say a very less values in itself. And I have a data number 3. So here my data set is ranging between a particular range, so it's not deviating much. But in data number 1, so there is a lot of deviation in one of the data set, and there is a lot of deviation again into a data number 2. So I can say that okay, yeah, so there is a very high chance that my data number 1 and data number 2 is skewed, maybe on a positive side or maybe on a negative side, lower side or maybe on a higher side. My data set is skewed, and it looks like that my data 3 is not at all skewed. Yeah, not at all skewed over here. So I can try to use the above formula, and based on this above formula, I will be able to do a math. So if I'm going to calculate a skewness for my data number 1, so it is going to be positive of 1.49. Just use this formula. So you have to find out the mean and standard deviation, which you will be able to find out quickly. I have already done my math. And here, so if I have to find out the skewness for this particular data, so it is going to be minus 1.36, just with the help of same formula. Yeah. Or maybe you can try to use like a library over here, so stats library over here, that is also going to give you the values. And here, so I will be able to find out skewness is equals to 0. And again, just by looking into this data, you will be able to find out the exact same thing. We have 2 over here, so which is not falling between the range of this data variation, rest of the data variation. So we can say that we have this kind of a data, and eventually it is going to form this kind of a curve if I'm going to use a normal distribution formula. And if I'll try to like plot it on top of this normal distribution curve, or if I'll try to form a bell-shaped curve, this is going to give me a tail. This is going to give me a tail on my left hand side. Or on a negative side, this is going to give me a tail, a data number 2. Now, if I'll talk about a data number 1, so this is going to give me a tail on a positive side. So on this particular side, on right hand side, this is going to give me a tail, because most of the data is like fluctuating between these ranges, but there are some data which is on a positive side, which is on a higher side. Similarly, so most of the data is fluctuating between mean, but yeah, so there are some data which is forming a tail. So I can say that this data set is basically an outlier data for me. Yeah, this is the advantage of a skewness you will be able to find out. Now here, so I have a skewness is equals to 0. So I can simply say that there is no outlier inside my data set. Data set is going to form a proper bell-shaped curve, a normal distribution curve over here. Simple, right? So positive skewness means whenever you have a skewness greater than 0. So yes, inside a data number 1, so we have a positive skewness with the help of this formula. In data number 2, I have a skewness lesser than 0. So yes, I do have a skewness in data number 2. And in data number 3, so I have a skewness is equals to 0 at the end of the day. Now, so here again, with the help of mean median mode, you will be able to find out a skewness. So just by doing a mean median and mode comparison, you can say, so again, without even using this skewness formula, you can say that okay, so whether my data set is a skewed one, and if it is a skewed one, then it is skewed on a left hand side, or it is skewed on a right hand side. Even that you all will be able to say, even that you will be able to do it with the help of mean, median and a mode, which I'm going to teach you in my upcoming lecture. Yeah. So just hang tight, and yeah, so let's get into our next lecture. So where I'm going to talk about this skewness with respect to a mean median mode, and even I'm going to talk about a normal distribution curve formula over there. So with that, thank you so much everyone. Take care and see you again.